So good morning everybody, myself Acharya Vishvendra and this is Ncert question answer question session discussion, and this is the chapter 3, which is motion in a straight line. So let's begin with the questions first. So there are questions initially based on the definition of motion. Then we have conditions for which motion is a straight line. Then we have point objects, kinematics equation, reference system, coordinate system, frame of references, inertial, non-inertial, then their characteristics. Then we have choice of axis, then description of event, then we have distance displacement, their qualities, their ratio, which is great, which is less, under what condition they are equal. Then we have circular motion and the concept of round trip, distance and displacement in that. Then we have a question based on circular motion, point moves from A to B in a circular motion, traversing angle theta, distance, displacement, their ratio. Then we have position vector of a certain point. Then we have distance from origin. Then we have position of one point with respect to another. Then we have the distance between them. Then there is a relation between graph and velocity. Then there is a concept of uniform velocity over there. Then we have the concept of making the graphs from a situation given. Then we have certain graphs given and we have to analyze that what physical situation they do represent. We have different cases like uniform velocity, non-uniform velocity, accelerating or deaccelerating or constant or at rest. So all the combinations are described over here. Then we have a question based on a position time graph, and we have to analyze the velocity of that particular graph. And then we are have a given numerical, and we need to find average velocity. Then we have to find certain things related to the graphs: initial velocity, position vector, average velocity, displacement. All of things are concerned, and we have to analyze when it is at rest, when it is moving along negative x-axis, when along positive x-axis, distance traveled, average velocity, etc. we have to describe. Then we have average speed, then we have velocity and speed, then concept of the ratio of them. Then we have under what condition they are equal. Then we have the definition of average velocity, then instantaneous velocity. Then we have graph and we need to find average velocity using the slope of the graph. Then we have a concept related to average velocity, average speed. Then we have a numerical based on certain points. We need to find displacement, distance, average velocity, average speed, average velocity when it reaches p, average speed. Then we have average velocity in vector form, then instantaneous velocity, then we have instantaneous velocity in another form, then graph of them. Then we have a question based on graph. We need to find average velocity, instantaneous velocity at different points, average velocity during different intervals. Then we need to find instantaneous velocity during different parts. Then we have to find instantaneous velocity in different intervals. Then we have a numerical based on position of a particle. We need to find instantaneous velocity, initial position, initial velocity, instantaneous velocity, position at t is equal to 2, average velocity between 0 to 2, then 2 to 4. Then we are asked about acceleration, then what is average acceleration, then what is instantaneous acceleration. In the next question we are given a graph of velocity and we need to find average acceleration during 0 to 10, then from 0 to 20, then 0 to 2, then instantaneous acceleration, then at t is equal to 4, then t is equal to 10, then instantaneous acceleration during 0 to 10 second to 20 second. And again we are given a graph of acceleration versus time, and we need to find acceleration during 0 to 10, then during 10 to 18, then during 18 to 20. Then we need to draw graph of that, and so the graph is given and we need to analyze the acceleration corresponding to different graphs, in which case it is 0, it is positive, it is negative. Then we have a question based on velocity time graphs area. So without sign, with sign concepts are discussed over here. Then we are given a graph of velocity versus time, and we need to find displacement, then average velocity, then distance traveled, then average speed, then ratio of average velocity and average speed, then acceleration at a particular time, then about kings, then from the graph we have to find average velocity, then average acceleration, then displacement, then we come across the equations of motion, first, second and third, including general forms. Then using those equations we need to find velocity, displacement, average velocity, average acceleration. Then there is a question on motion under gravity. We need to find time of ascent, descent, flight, maximum height, speed at 1/3, speed at 1/nth. Then we have a question based on a tower problem using the same concept. We need to find time, then speed, then maximum height. Then we have a graphical question on motion under gravity. We need to find velocity time graph, then speed time graph, then acceleration time graph. Then we have a displacement time graph. Then we have position time graph, distance time graph. Then there is a numerical based on that. Then there is a numerical based on first equation of motion. Then we have a car stopping distance, then variation of speed and dependency on the stopping distance. Then we have a question based on reaction time. Then we have concept of relative velocity, then a numerical on relative velocity. We need to find relative velocities with respect to each other. Then we have conditions for maxima and minima. Then we have a two particle problem. Their coordinates are given. We need to find their positions, their velocities, relative velocities. Then relative position, then the graph of relative position with respect to each other. Then we have position time graph, and using that we need to find velocities, then relative velocity, then again a numerical based on two particles in which two graphs are being given over there. Using the graphs we have to analyze initial position of A and B, then position of A with respect to B, B with respect to A, velocity of A and B, instantaneous position of A as a function of time, then B as a function of time, then relative positions of two things. Then we have another question. We need to find position of Q initially, finally, initial position of P, then position at which they meet, velocity of P, Q, ratio of velocities, position as a function of time, position of Q as a function of time, position of P with respect to Q, Q with respect to P. Then we have another problem on two particles, and we need to find their velocities, relative velocities, etc. So this is there are total of 198 questions in this, and I hope these will optimize your time and energy. So just read this question and read NCERT just to find answers of these questions. In this way you can optimize your time and energy. Thank you and have a nice day.